Today we're going to talk about one of the questions that we get sent in a lot at Numberphile. And the question is, well, Brady, what's the question?
The question is, why does 0 factorial equal 1?
Right, why does 0 factorial equal 1? So let's start off with a quick recap of what a factorial is. For a whole number, let's pick a number n. N factorial, which is written like that, n with an exclamation mark. This is equal to, you multiply all the whole numbers less than and equal to n. It's n multiplied by n minus 1, multiplied by n minus 2, multiplied by, and you keep going down, and you'll go down to 3 times 2 times 1. A quick example. Let's do 5 factorial. 5 times 4 times 3 times 2 times 1, and if you do that, it's 120. Okay, the question we've been asked is what is 0 factorial? So the way you can answer it, one of the ways you can answer it is to complete the pattern. Let's complete the pattern, this pattern in particular. 4 factorial is equal to 5 factorial divided by 5. If you can see that, if I take 5 factorial here and divide by 5, that means I can knock off that 5. You end up with 4 factorial. So 5 factorial divided by 5, or 120 divided by 5, that's 24. That's 4 factorial. 3 factorial is going to be 4 factorial divided by 4. That's 24 divided by 4. That's 6. That's the answer to 3 factorial. 2 factorial, 3 factorial divided by 3. 6, which we've just worked out, divided by 3 equals 2. 1 factorial, do it again, is 2 factorial divided by 2. 2 factorial is 2. Divided by 2, we've got 2 divided by 2. Yeah, that's equal to 1. And now this is where it's getting exciting. Do you feel the anticipation? So 0 factorial, we're going to complete the pattern. 0 factorial is 1 factorial divided by 1. 1 factorial is 1. It's 1 divided by 1, and that is equal to 1. So 0 factorial is equal to 1. You complete the pattern.
Who says the pattern has to be complete? Where's that rule come from?
I guess it doesn't necessarily have to be a pattern that completes. It is a pattern that completes, though. Let me try another way to explain it.
Let me continue the pattern first. Does that mean
Shall we try?
negative 1 factorial would be next in that sequence?
Let's see what happens. I'm not sure what's going to happen. Let's try. Minus 1 factorial. So what should I get? 0 factorial divided by 0. 1 divided by 0.
Divided by 0.
You've broken maths, Brady. Stop that. Another way to explain what 0 factorial might be. N factorial is the number of ways you can arrange n objects. Let me just try and show you what I mean. Let's get some objects. I'll get the wallet out. I'll get some coins out. You see, who says mathematicians don't make a lot of money? There's literally 50p here. Let's pick a silver one and a 5p, right. 3 objects here. And how many ways are there to arrange 3 objects? There's 6 ways to do it. It's 3 factorial. Let's just check them. That's 1. That's 2. Or we could have this one here. That's 3. That's 4. Or we could have, I think it was that one we didn't have at the front. So that'd be 5 and 6. If we take one away, we have now 2 objects. How many ways are there to arrange 2 objects? That's 1. That's 2. Let's take one away. How many ways are there to arrange 1 object? There it is. There's 1 way to do it. 1 way to arrange 1 object. Now we're going to take the last coin away. This is where it gets a little philosophical. We have 0 objects. How many ways are there to arrange 0 objects? There's 1 way to do it. There it is. Do you want to see me do it again? There it is. Slightly philosophical, but we say there is 1 way to arrange 0 objects. So again, the pattern holds 0 factorial equals 1. Just to continue the idea just a little bit further, if we're talking about factorials, let's try and graph them. So let's have 1, 2, 3, 4, 5. 1 factorial is 1, so if we call that 1. 2 factorial is 2, so it's somewhere about here. 3 factorial is 6. I don't know, somewhere like this. 4 factorial is 24, so that's going to be actually quite high up here. And then 5 factorial is going quite high. If we join these together, I've also said that 0 factorial is 1, so I reckon this is the graph. So in theory, we should be able to get values for in between, like say the number 1.5. 1.5 factorial. What is 1.5 factorial? So mathematicians have done that. They've generalized the idea. And there is the idea of 1.5 factorial. We call it gamma. That's the Greek letter gamma. We call it gamma of, and the way we write it, actually now this is getting a bit more sophisticated. We say gamma of n is equal to the integral between 0 and infinity of, let's pick something, t to the power n minus 1 multiplied by e to the power minus n dn. That's, some people won't be familiar with that, some of you will be familiar with that, some of you won't be. It's a much more complicated mathematical idea, but this would agree with the factorials, but it gives you in between values as well. It plots this line. There is something I do need to say. It's slightly unexpected, but if we take a value for a whole number, gamma of n, and n is whole, this actually gives you n minus 1 factorial. So be careful of that. That might catch you out. Bit of a pain, that. So what's the point of having a function that will give you factorials in between whole numbers when you can't arrange 1.5 objects? So it's a generalization. And it turns up to be quite useful in many things. Particularly, I'm thinking of probability. You can use them in formulas that you find in probability, where you can, when you're thinking about continuous time, instead of just arranging objects in discrete probability, you're now starting about thinking about continuous events. Time is the best example. Then you start to generalize the ideas, and therefore you need a generalized factorial. 9, 6, and 3, 20, 44.